Thursday's your test. You better be here. Next Tuesday's no class. I will have a recording online going over half of the final exam. Next Thursday is the other half of the final exam review. Will be here. And then Tuesday, May 7th is the final exam. Okay?
Tony, you're not going to believe me when I say this.
So,
I do actually have an appointment that Tuesday.
what, the 7th?
2 of them.
Let's just be done before 5 o'clock.
We'll see.
We'll see.
You either got to take it then, or you can take it the next day when I'm giving my final for my other class, because that's the last day I'll be here.
Yeah, it'll be one of those. I have like 3.
So tell me, and I'll tell you when my final exam for my Calc 1 class is. You can come to that one.
All right.
Because then I'm done. I won't be back until July. At least here. For anybody who's wondering, I'm teaching stats in the summer, actually, and next fall. So don't think any of you have to take stats, but everybody always seems to ask, so I figured I'd tell you.
They didn't have any classes available for me.
That sucks.
Delay graduation. Take this class.
Well, technically, you should be able to graduate.
It won't, because I have to take calculus-based physics too.
Yep.
Right, but you should be able to actually go to graduation. Like, if you want to, so yes, you won't get your diploma, but you can physically go to graduation early. Okay. Yeah, the paper doesn't,
I don't
yes.
care. Let's go with the graduation.
I
just
you know.
want a piece of paper.
Just giving you that option. And wear a dress.
Also, like, if I went to graduation,
All right,
I'm leaving after my name's called.
let's go to this. So, as I said, we're going to do the end couple questions first. So, because 1 through 8, I really kind of covered last class, but we'll go over those again. 9 and 10 are problems that I haven't gone over yet. They were the stuff from the interval of convergence and radius and the power series and Maclaurin series. So the first question is, find the radius and interval of convergence for the following problem. So how do we find radius and interval of convergence?
If I remember correctly, we do the absolute conversion. Well, we know it's converging, so
So how do I determine what my radius and interval of convergence is? What tests do we use?
the absolute convergence test, right?
Well, there technically is no such thing as called the absolute convergence test.
Or that where you do the absolute value of a sub n plus 1 over
The ratio.
that.
All
I
right,
can
so we
do
have,
it. I just don't have it.
so we have to do the ratio test. So it's an plus 1 over an. All right. So for this one, and remember, in essence, you don't have to worry about the -1 to the n because that would cancel out in the first step anyway. So we have the absolute value of x minus 1 n plus 1 over 2 n plus 1 minus 1 times 2 to the n plus 1.
I'm sorry, why was the x put there?
What x put there? That x?
Never mind. Sorry.
That's okay. Yes, I did the keep change flip. You keep the first fraction, you change division to multiplication, and you flip the second fraction. It's because
Or you can write it.
I don't know. It's because middle and high school teachers come up with acronyms to get people to remember things.
And then we group all the fun stuff together.
All right, so now we're at this point. So, right, the next thing you want to do is put things that are similar together so you can cancel things out. So my x minus 1 to the n plus 1 is the same thing as saying that times x minus 1. over the x minus 1 to the n. I have 2n minus 1 and 2n. Actually, we'll put the 2n minus 1s together. So this one, this is 2n. Why didn't it change colors? This is 2n plus 2 minus 1. So this ends up becoming 2n plus 1. And then I have 2 to the n over 2 to the n times 2. So now I can cancel out those two things, and I can cancel out those two things.
Then we want to group it all back together, right?
Yep. So I now have two n minus 1 over 4n plus 2 x minus 1. On the top? Oh, that's okay. I multiplied those two. All right. And we're looking for, this is the limit as n goes to infinity of this. So the x minus 1 can, in essence, come out because that's not, we're going to have to worry about that. So this piece over here, I'm going to divide everything over here by n, and I end up getting 2 over 4. So this goes to 1/2 x minus 1. And that has to be less than 1. Yeah, because this, the n's cancel out here. This becomes, so this becomes 2n over n minus 1 over n, 4n over n plus 2 over n. So that becomes 2 minus 0 over 4 plus 0, which is 2 over 4, which is 1/2.
Yeah, because it all is really.
Yeah. So I can pull out the 1/2. So that means x minus 1 has to be less than 2. So that means -2 is less than x minus 1 is less than 2. Because 1/2 can never be negative.
Yeah, exactly. So how did it? X minus 1 less than 1.
I multiply both sides by 2. So we add the 1 over to both sides. So -1 is less than x is less than 3.
And that is our radius.
So your radius is 2. So because, and you can figure out here because that difference is 4, so the diameter is 4, the radius has to be 2. So my radius of convergence is 2. It'll always be the number that's here before you break up the absolute value. That's your
So why do we
radius.
still break up the absolute?
Because you have to find your interval anyway.
The radius is always half of the interval.
The radius, because the interval, the range of the interval is basically your diameter. The radius is half of it.
There's always gonna be that number.
It'll always be whatever number you have before you do your absolute value piece. Yeah.
Unless you really messed up.
Well, yeah, but then you're going to have it wrong anyway. All right. So that's my radius of convergence. I'm almost done with my interval of convergence. I have -1 is to 3. Problem is I need to figure out if it can equal -1 or equal 3. Because remember, the ratio test, if it equals 1, doesn't tell me anything. So I've got to plug in the -1 and 3 and look at those two as separate situations.
You plug it into
The original problem. So we go back up to my original problem. We now know that it's -1 is less than x is less than 3. So we're going to plug in x equals -1 and x equals 3. So if I plug in -1, I get -2 to the nth power. The negatives are going to end up canceling each other out. The two ends are going to end up canceling each other out.
So it's just
So this becomes -1 to the nth power and 2 to the nth power. So those two will cancel each other out, and then that and that will cancel each other out. So we end up getting 1 over 2n minus 1. And that goes to that does go to 0. The limit does. So that means it fails the test for divergence, so I can't use that. So how do we determine if that converges?
I figure rid of the -1 to the
Because I have -1 to the n times -1 to the n, which would then be 1 to the n, which I don't need. That -2 to the n becomes -1 to the n times 2 to the n. What's -1 times -1? Right. 1 to the n is always right. So do I need to multiply? Do I have to put something to saying I'm multiplying by 1? No, that's why it's gone. All right, so we need to figure out some other way to show, does this converge or diverge?
alternating series one?
It's not alternating. It's not alternating anymore.
Oh, not anymore.
What does it look like? Yeah. Okay, it looks like a P series. Looks like a harmonic series, really, because P is 1, right? Okay, so if we're going to compare it to 1 over n, it's got to be bigger than 1 over n, right? Because this is divergent. So if I subtracted 1 from that, that means my denominator is smaller. But if I have multiplying it by 2, that really, I can't really say this, right? Okay, so then I can do the what? There was another test I can use, the limit comparison test. Right, so we're going to divide. So I have the limit as n goes to infinity of 1 over 2n minus 1 divided by 1 over n. So flip it So I get n over 2n minus 1. And that goes to 1/2. And what did the limit comparison test say?
This is today's not the day.
If it equals C and C is a finite number greater than 0, then either both series converge or diverge.
Right. It depends on what the other series does. We know 1 over n diverges. Right? Because that's a harmonic series.
And this also does,
So then that has to diverge by the same reason.
which means that it does not work.
The limit comparison test says it does what the other series does. And we picked the series we chose was divergent, so therefore this one also has to be divergent.
And so -1 does not work.
All right, so -1 does not work. We now have to try negative or +3.
Probably this
Not necessarily.
Yeah, no.
So -1 to the n, 2n minus 1, 2 to the n. And I had, what was it, 3, it was +1, right?
-1.
Oh, it was -1, so that's 2 to the n. So this ends up going to -1 to the n over 2n minus 1. Now this one is
Alternating series.
an alternating series. So we can use the alternating series test for this one. The alternating series test has 2 statements. What are the 2 things that I have to check for an alternating series test?
An alternating series.
Well, yes, we know it's an alternating series. There's 2 conditions we have to meet.
So one version has to be less than
Yeah.
the end.
Yeah. So it's got to decrease, right? Does this series decrease? So remember, we're looking at, in essence, just 1 over 2n minus 1. Does that decrease as n gets bigger? Yes. We can look at that one. The top's not changing. It is absolutely decreasing. Okay. So the second part of that statement is what?
Does it fail the test for divergence?
Basically, yes. So does this go to 0? Yes, this goes to 0.
Hey, it fails.
So therefore, this is convergent based on the test for alternating series test. So my interval of convergence is -1 to 3. And you can write it either way. It doesn't make much difference to me.
Oh yeah, we did it
Did
best.
you write the n+1 version somewhere?
No,
You just
I just assumed.
how did you? Oh, that's the piece of you ignore that. Never mind.
Yeah, you ignore you're ignoring the alternating series part, the -1 to the n. Based on the alternating series test, yes. So it converges at 3 and diverges at -1 and converges everywhere in between.
I have a question about that. And
Yes.
over 2n minus 1. And you know that was 1/2.
Divide them all by n's. So I got 1 over 2 minus 0, which is 2. All right.
So our interval is -1 less than x less than equal to 3. Wait, no. Well, yeah, 'cause this shit converges. 3 converges.
You put a weird bracket around it.
That bracket's to show that it's included, right?
Yeah,
Oh,
the
yeah.
bracket includes.
Yeah.
Either one of those. You can write it either way. That's interval notation. That's
That's fine. I was just like,
number line notation, or I can't remember the name of that one.
it's all right.
Set notation.
Yeah.
I only know that because what it's like.
All right. So we good with this one? As good as you're going to be?
Yeah, so, I have a question.
Sure.
The application of the limit compression. Um, Finding the radius, we used the
Ratio test.
ratio test. So, and we know that we're using the ratio test because how do we know to use the ratio test?
You will always use the ratio test for this. So the reason we always use the ratio test for this is it's the one that gives me
Yeah.
all directions. So it tells me if it's less than 1, it's convergent, things like that. So we can actually solve for that. So that's why you're always going to use the ratio test for these problems. Unless for some strange reason the problem looks like you can do the root test.
Is there homework on?
No.
I have a question in regards to number 29 on the homework. We didn't use the ratio test. We used
Correct. But that was
that's
so
arctangent.
right.
But like, can you use the ratio test for arc? Like, if it was like arctangent.
You could.
Yeah.
You could use the ratio test to show that the geometric series converges at 1. You wouldn't have to. It's more work than you need to.
Oh wait, no, that's a completely different. Never mind.
You could have. It would just been a lot more work. So, all right. Next. Let me do this first. Remember this table?
Yeah.
This is the day you weren't here. Huh? All right.
Oh, this is going on my part. Oh Jesus. This
You
is
do
so-
not need the entire thing.
Oh, well. How do I know which one I need?
I'm going to tell you.
Uh-oh.
Look at that.
All right. So the one on the actual review test is that one. Okay. So the only ones you're going to need would be those 3.
That's inverse tangent.
Yeah, arctangent, yeah. Okay. So you will not need those. Those are the only 3 that could possibly, those are the only 3 I will put on the test. So it'll be one of those 3. And for those who are still doing your WebAssign, arctangent's right there.
That's 216.
Yeah. Well, hold on. Yes, you can do it by the 16th. Because I think technically that's the last day of finals. Might be the 15th. It's fine. I know I won't have my grades in before then.
R is radius of convergence.
Yep.
I have a question about the, so we have the trig function on the left, and in the middle, we have the
Summation.
summation, and on the right, we have. uh,
They just wrote it out. Yes, they wrote out the summation.
Or writing out, okay, yeah, so the section where, the sequence is written out,
That's the most important part.
that's what we use to figure out
Number 29.
yeah, so, that's how we get to the middle one.
Yes,
Oh,
that is the middle one.
okay.
So this bypasses you having to actually find that.
Thanks, Harold. We can probably get there at some point.
You can, like, we did it earlier today. Like, I actually went through and found the arctangent window for number 29.
So
So,
this is a infinite series.
yes, these are infinite series. All right. So this question says evaluate the infinite series as an infinite, or the infinite integral as an infinite series. So you just wrote down what sine of x was. So let's look at this in pieces. We know what sine of x is. What's sine of x squared? All you're going to do is replace the x with x squared. So we have summation of x n equals 0 to infinity, -1 to the n, x squared, 2n plus 1 over 2n plus 1 factorial.
Would we combine the top part and that?
Yes. So this ends up being x to the 4n plus 2 over 2n plus 1 factorial. Okay.
Or multiply x squared.
Now I've got to multiply it by x squared because I want x squared of sine squared. So I'm going to take this and multiply it by the x squared. I can move the x squared inside.
And multiply it again.
And then you're going to add the exponents. So we're going to move it inside first.
Why add that?
You'll see in a second. So I have -1 to the nth power. When you have like bases, you add the exponents. So this becomes x to the 4n plus 4 over 2n plus 1 factorial.
And that's our answer.
No. I'm missing one more piece from my original problem. I wasn't looking for x squared sine x squared. What was I looking for?
The integral
The integral of that.
is
So we're going to do the integral of the summation. So when you're doing the integral of the series, you literally just treat it as you're integrating for the x. So
raised to the power by-
this equals, yeah, you're just going to raise the power by 1 and divide by it.
Okay, I just wanted to make sure.
So -1 to the nth power. This is going to be x to the 4n plus 5. 2n plus 1 factorial times 4n plus 5. And that's the answer.
The
When you're doing integration with the n, you treat n just like it's a constant. So the
if I
4n
wanted to, I could pull out.
Everything except for the x, you're not really worrying about. So technically, like this stuff stays. That's why that's there.
Can't we evaluate? Why can't we figure out what the sum is, and then take the integral of that?
You could write out
Yeah,
the
'cause-
values.
'cause that's an alternating series, so we could apply the alternating. Wait, no,
No, we're not trying to figure out if it converges or diverges.
We just want to take the integral.
We want the actual value. You could have technically written this one out and then done the integral of each of the pieces, but you would have gotten the same thing. That's actually how I showed it when I taught this in class.
If we do the alternating series test, doesn't that tell us what it converges to?
No. It just tells me it converges. The only ones that we know converges to a value is the geometric series. That's the only one that we have of a thing that converges to a specific value if we could find it. The point of this is if I asked you to find me the integral of this, you couldn't do the integral of this. You couldn't do substitution. There's no way to do the integration of this.
Yeah.
Now that we have this summation here, I can estimate the integral of it. I can actually find a value of it, which is what this is helpful for.
Why don't you apply the, so on the top, we added in one, right?
Yep, yep,
And that's derivative, right?
yep.
I should put it on the bottom.
What's the power rule for the antiderivative?
Without drawing.
No, that's not
I
that.
think
That's
under-
derivative.
Yeah, it goes underneath. It went under. Like is x raised to whatever, and then you take the integral. It's x raised to whatever plus 1 divided by whatever plus 1. So
That's the power rule for integration. All right. Those are the only two questions that you're going to have on the test that are not, just tell me if it's convergent or divergent. Okay. All right, is this convergent or divergent?
I have converted
Why?
by a direct comparison test.
So I wrote by the limit.
You can always do the limit comparison test.
So
You absolutely can always do the limit
so I
comparison
did a
test.
lot more.
What did you compare it to?
I said AN and BN
Right. What did you set BN to?
squared.
Okay. So you have n minus 1 over n to the third plus 1. And you're comparing it to 1 over n squared. Does this converge or diverge? That converges. Correct. By p series. This p equals 2, which is greater than 1. All right. So for us to do direct comparison.
Oh, that's the limit.
No. Okay.
What's that?
This is what we're comparing it to. So when you're looking at direct or limit,
Yeah.
when you're looking at the comparison tests in general, we need to know what we're comparing it to. Okay. So this one looks like 1 over n squared. If you cancel other stuff out and change that there, you're going to get 1 over n squared. All right. For me to do direct comparison, since this converges, this has got to be greater than that. Okay. So the question is it greater than that? Okay. So if you can't determine that, that's where the limit comparison test comes into play. If you can,
That's a direct.
that's if this is true, that's direct comparison. So we have to show that it's true.
I split it up.
Yes, that's literally, yeah. What did you take away first?
I took away the bottom.
All right. So you had n minus 1 over n to the third.
Yes.
And that is bigger than that because you're adding 1 to the bottom. Yes, that would be true. And then you said, okay, so then that would also be true.
And then I did an equal sign.
And that's 1 over n squared. Then that's direct comparison. That is true. So this is convergent because of direct comparison. Now, if for some reason, if you didn't want to do that, limit comparison is a completely valid way to do it. It will work. Okay. So it's one of those things like if you can't show that that's true, then you do the limit comparison test. All right. So the limit comparison test is just saying that I have n minus 1 over n to the third plus 1 divided by 1 over n squared. So I got n to the third minus n squared over n to the third plus 1. Divide everything by n to the third. And we get 1 minus 0 over 1 plus 0, which is 1, which is greater than 0. So therefore, convergent. And this was direct convergence
I think
of comparison.
my trouble with the limit comparison test is I often don't know what to pick for my B of N.
You do the same thing you would do for direct comparison.
Just break it down.
So the only reason we have the limit comparison test is if you're not sure that that's true.
If the arrows flip.
If the arrows flip, then right, it won't.
Comparison
Correct.
starts. Okay.
Right.
But you can keep breaking it down.
And as long as that stays true, you're good.
Yeah, no, what I'm saying is like so let's say I went with direct comparison to start and I broke it down and at some point the arrow flips and I'm like, okay, this direct comparison doesn't work. But
Keep going because you can do limit
keep
comparison.
going and then to the most distilled version of whatever the fuck
Yes.
I get, I can compare that would be my B of N.
Yes.
And then I can compare it to my
Correct. Yes. So limit comparison, direct comparison, you get the B to the end the exact same way. The only difference is you just can't tell me if it's actually less than or equal to, or less than or greater than if it was divergent. So same concept. So either way would work. Both answers are completely correct. Both
There should
answers.
be a difference.
This is logic. All right. Still not happening.
It can't be logic, there's different tests to it, I feel like, you have to know things, like, one that's.
That's logic. It's literally what logic is.
Yeah, but, well, formulas are all science.
But no, proofs are logic. Geometry and logic is proofs. No, that's literally the definition of logic.
Like, I know if I jump from a building, yeah, I'm gonna break my legs, that's not a proof, that's logic.
No, that's not logic.
But if I-
No, see,
That's
the,
cause and effect.
the mathematical definition of logic is to take a list of steps to prove your outcome. Your in essence, that is what geometry is supposed to have taught you, which it didn't, and they stopped that a long time ago, unfortunately. This is exactly that. You are taking a logical flow of steps to get to an answer. You can take multiple paths to get there, and that's what makes it different than an algorithm. An algorithm is one set of steps, you follow it like a recipe. This, you have multiple ways to get to your final answer.
Well, yeah, it's kind of like a recipe, but you have to know, like,
No.
the recipes to do it.
This is not like a recipe. This is the opposite of a recipe
How is it not a recipe?
because you don't have a set of steps. It's like, I'm not telling you have to do this, 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 this.
Well, that's what the test says.
No, I'm saying, but
Yeah, but you don't know which test to use.
Right.
don't know what to use.
you can use any of them.
That recipe. I don't know, it's a little weird.
Just follow along with the process at this point. All right, what am I going to do for this one? So, convergent or divergent? We'll go with that one. Why?
Because, why
The
is-
comparison test. I did the ratio test.
Okay, thank you. Well, actually, I don't,
did both.
I did the root test.
yes, I was going to say, this one should be the root test.
Did not.
I think you probably could do the ratio test on this one, but the root test actually is easier because we have both raised to, because we have n in the powers. That's when you think about the root test, when you have the n in the powers. Okay, so my root test, so we have the nth root. So in this case, I got to make one little modification to this because I want to put it together. And that's all to the nth power. All right, so I've got this. How do I find the limit of that?
I actually did out here so that they're all nice and pretty.
Okay. You could do that.
I divided it all by into the third.
Okay, so I'm just going to do that. So if I divide everything by n to the third,
Yeah.
my top is now n squared over n to the third. And my bottom is 1 over n and n over n to the third. Actually, let me take one step back because I don't think you're going to get how I went to there.
Exponent.
Yes.
Gets me.
Sorry.
But if you do it all out,
You don't have to do the
you
exponent
don't have
rules.
to deal with the exponent rules.
Correct.
Few extra words.
So this comes out to be 0.
And in the root test, a 0 is good.
Yes.
Does that mean
0 is less than 1. So therefore, this is convergent.
would you take off points if we just put convergent, or would you?
No.
Because it's absolutely convergent.
Yes, it is absolutely convergent. You just have to say, you have to tell the two things I want to see. Well, there's three things I want to see. I want to see convergent or divergent. I want to see which test you used. And I want to see the work that shows me that test. Okay, so if you told me the root test and then you showed me a whole bunch of limit comparison stuff, you're not going to get credit for that. So if you showed me the root test, you did limit comparison test, then you did root ratio test, then you did root test, you will get credit for that because I still see the root test there. That work for you, Bo?
Yeah. but you all night.
What if I,
Yes.
what if I can't remember the name of the test?
You'll lose a point or two.
So I have to say convergent by root.
Yes. Yeah. And if you put the information, like, I'm not going to mark the whole question wrong because you have all the work there and you told me it's convergent. That's right. But if you don't tell me the test name, I'll probably take off a point for that.
Would you like one?
Oh, no, I'm good. Thank you. All right. We good with this one?
Can't do it.
This one. All right. So what are we doing for this one? The what? Sorry.
I did the integral test.
Yes. This one's the integral test. And you should look at this one because ln of n and 1 over n kind of work together. So makes my life a little bit easier there. All right. So we're going to do the integral test. So in this case, I have 1 over x ln of x to the 1/2. So I'm going to make ln of x equal to u. And then 1 over x is du. So I'm really doing the integral of the u to the negative 1/2 du.
Add one drop of that.
And we're going from 2 to infinity. So this ends up going to 2u to the 1/2. So I have 2 square root of ln of x from 2 to infinity. And this goes to infinity.
So it is
This is divergent. Integral test. I didn't put this on there and I should have asked you beforehand. What were the 3 conditions for the integral test?
Positive,
Positive,
decreasing,
decreasing, continuous.
continuous in the fucking
In the interval they gave you.
ends or whatever.
Correct. So this is continuous. We know that much. It has to start at 2 and not at 1 because the ln of 1 is 0. So that would end up not being continuous. So this is continuous. There's nothing on the top. So this is decreasing, obviously.
Starts with those 3 rules.
Yes,
if n were to equal 1 here.
it wouldn't work.
So, but like if it did, what would
It would be
write?
discontinuous. You couldn't do it because that point doesn't exist.
So was there another test that we would use, or is it
No,
just like we
you-
just can't do it?
You would say this sum does not exist.
Okay.
Continuous, decreasing, and positive.
And positive. It can't alternate or go back and forth. So like if you're doing cosine of x, it goes positive and negative. That wouldn't work. So you couldn't do the integral test of that because it was positive and negative. This one, most situations you see it, positive is pretty easy to determine. Because as long as the value doesn't alternate, you're good. Continuous, as long as, and like in this case, give me 1 second here. Continuous is as long as there's nothing in the bottom that's going to, or the top that's going to make it not work. So in this case, the only thing that would not work would be that it's got to be greater than, because it's got to be positive inside the square root, and ln at 1 is 0. So that'd be the square root of 0, which is 0. The bottom would be 0. That would work. But at ln of 2, it's fine. So we know that's continuous there. Decreasing sometimes is a little hard to determine. In this case, it's pretty obvious because the bottom's changing and the top's not. So we know it. If both the top and the bottom change, you might have to do the derivative to show me that it is decreasing. In this situation, you don't have to, though. What was your question?
For the integral test, if you have a weird function that is increasing at some point and then starts.
As long as it is decreasing as for the majority of the time. So basically, as long as it increases and then decreases after that point, you're fine. What you don't want to do is you don't want to have it increasing, decreasing, increasing, decreasing, those type of situations. Again, like your trig functions. You do not have to have that, like, so we did a problem in class that had where it was increasing to E and then it was decreasing after that point. And E was, because I think we started at n equals 1 in that situation. So E was a couple points in, that's fine. Because as you're going out to infinity, after E, it's decreasing. So it's basically decreasing as you're going to infinity, you're good. So what you don't want is it going back and forth is what you don't want. Yeah.
So considering that we can use Desmos in our tests, is plotting both graphs and then, or plotting the graph and then like seeing that it's decreasing, is that like, because that's what I did. I just plugged it into Desmos.
Yeah.
I'm like, yeah, that's decreasing.
Then just quickly sketch me the graph and say it's decreasing by the graph. This way I know you've done something to tell me that it's decreasing.
And the same principle can be applied to if we're doing the alternating series test and we want to compare some then with the
Yeah,
one.
99% of the time it's going to be obvious.
What's the next one?
Then let's look at number 4.
Yeah, for this one I zoomed in a lot and I figured out, okay, this one's bigger than that one forever. Okay, okay.
Yeah, I respect that.
All right, so let's look at this one. This one is what?
I have to-
Yes, this one's alternating series. It's got that piece there. That's alternating series. Okay. So we've got to show two things. The first thing is that it's decreasing. So we have to show that n plus 1 to the 4th over 4 to the n plus 1 is less than n to the 4th over 4 to the n. So you can look at it. The easiest way to look at this is to basically say that the bottom is going to be is getting bigger faster than the top is what you're trying to show. So you're right. This one is not nearly as obvious as some of the other ones that we have done. So you could look at it like that. Honestly, in this case, I would have just did a couple numbers to show that it does, because it's not going to change. Like this isn't one of those ones that's going up and then down and then up and then down. It's going to eventually get to a point. So it's either always increasing or always decreasing after a certain point.
Right.
So, and I think the point of this one is actually 3. I think it's 3 if I remember right. So, huh? I think it's 3 because 3 actually makes the top and the bottom equal.
Oh,
Three.
No, so in the other one, because it's 3 plus 1, which is 4 to the 4th, and then 4 to the 4th. So it's literally the exact, that's 1 on that side. So if you want to graph it, that's fine. And you'll get a graph that looks like this. And you can see after this point, it's pretty close to 2.88. There you go. It's decreasing.
Oh, I didn't do it like that. I graphed x to the 4th, and then I graphed another one 4 to the x, and then
Oh, you found out where they intersected?
no,
Oh, what did you do?
no, I did do that.
Okay. I'm like, that would be the way to do it.
Oh yeah, no, I graphed that, and then I graphed x plus 1 to the 4th
Oh.
divided by 4 to the x plus.
You got to remember, so when you're graphing x to the 4th over 4 to the x, you're graphing every possible option of x, which would include x n plus 1 and stuff like that. So this is showing you it's like, okay, after this point, it's decreasing.
Yeah, I was not able to make that leap. I just wanted to see the two graphs and just look at which one
So if you graph the other one,
on top of the other.
was x plus 1 to the 4th, it should just shift it over.
The red one is on top of the green one forever.
Yeah, it just shifts it.
Yeah, but like I
Yes.
get it. I get that it shifts it. but
Yes.
I didn't even notice that it shifted. I just saw that
Oh.
the red was on top of the green.
Right, which is all you really care about.
Yeah.
And that's fine. Yes, you actually don't have to. You literally can just look at this one and you're fine.
So which one?
So this one decreases.
I did have trouble with finding the limit. I just said 0 because it looks like it's going to 0.
Okay, we'll do that in a minute.
So I just kind of assumed.
All right, so next thing we're looking at is the limit as n goes to infinity of n to the 4th over 4 to the n. So how would you like to show this limit? That's the question.
The easiest way possible.
That doesn't.
I agree.
What test would you like, or what would you like to try?
I wasn't really sure that you could apply like test to it because that's not a sum. That's a limit, right?
So the series and the sequence, you can use the same tests. So because if the series converges, then the sum has to converge. Or so if the series converges, the sequence has to converge. All right, because otherwise, if the sequence doesn't converge, then the series would diverge. That's this concept. So if the series converges, then the sequence has to go to 0. Does that make sense?
Yes.
Because that's the opposite. That's actually the opposite of the test for divergence. The test for divergence states that if it doesn't go to 0, it diverges.
Yeah.
Okay. So if it converges, I know the sequence has to go to 0. Okay.
Or something.
Or no, it has to go to 0.
Oh, okay.
Because if it doesn't go to 0, it diverges.
That's the
Right. It's the opposite of the way it's the converse of it. So I can't say, so the test for divergence tells me that if the series goes to something other than 0, it diverges. Okay. It doesn't tell me anything if it goes to 0. Okay, so if it goes to 0, I don't know. It could diverge, it could converge. But what I do know is that
Oh.
every series that converges, it has to go to 0.
Okay,
So,
sorry, I got it confused.
That's okay.
The limit has to go to 0,
correct,
but the sum doesn't have to converge to 0.
correct.
Ah,
Yes. So this has to equal 0. The problem is I don't know it does yet. So,
yeah.
no, for the alternating series test, it has to equal 0. Otherwise, it fails the alternating series test. So we need to show that this limit goes to 0. I can do that using any of the other tests that I have. So this one right here, let's use the ratio test. Simplest test to use for this because I've got multiple things with the ends. So we're going to look at the ratio test for this one.
I love the ratio test. It's my favorite.
So I've got n, or what is it? N plus 1 to the 4th over 4 to the n plus 1 and 4 to the n over n to the 4th. So I got n plus 1 over n to the 4th and 4n over 4n times 4. So I got 1 plus 1 over n to the 4th times 4.
How did you just do that n to the 4th to turn it into 4 times 4?
4n plus 1. The opposite of that is 4n times 4 to the 1. Same basis, you add the exponents.
That's
Yes, that's what I did. I changed this to that.
Did you ask that last class?
Yeah. He actually asked it in the first problem. Oh, you're right. It is divided by 4. So it's 1/4. Which actually makes a really big difference in this problem. Which is less than 1, therefore convergent.
Is it because you divided everything by n and then?
And this?
Yeah.
Yeah. Because there was an n already on the bottom, so I didn't have to divide by n. The n was already there. Because I just basically broke this up. N divided by n is 1. 1 divided by n is 1 over
Right,
n.
yeah, so you could just say that that goes to 0.
Yeah.
And once the 4th,
This goes to 1/4. Yes.
fraction, 1/4.
1 is 1, 4 is 4, 1 over 4 is 1/4. All right, so the ratio test says that is convergent. Because that is convergent, I now know that that is true. So convergent alternating series test via ratio test. Yeah.
If we come across trouble proving the second requirement for the alternating series test, the the way forward is to apply the ratio test
Yeah.
to that limit.
Ratio test is one of those great tests. It just works and it brings you a lot of different things that you can use to break things out. It's really a nice test. Problem is when it hits 1, then it doesn't work anymore and we have to try other things. Huh?
It's stressful for you.
Or drive you insane and if it hits 1. All right. So what do we got for this one? Stop hitting that button.
Pretty sure I did this wrong. I got diverges.
The question is why?
I have some bastardized version of the limit test.
All right. So
Correction. Yeah, these are arrows. Yeah, because the direct comparison, the greater than, the less than flips, so that's not. And I compared it to. Wait. I did it wrong.
all right. So what should we try?
We should try the direct comparison test. Break it down, and then after we find out that it doesn't work, we can use the limit comparison test, except do it the right way, not the way.
All right. What's the first thing you should always try?
I did the limit as n approaching infinity, and then I divided everything fourth.
End of the third. All right. What the first thing you should always try is the what?
You're gonna divide by n.
Test for divergence. So let's try the test for divergence. I'm sorry. You need to speak a little louder, Bo.
I know, but then when I'm wrong,
Sorry.
All right. So the test for divergence states that we do
This one really simple. Yes.
you gotta know how I'm
all right. So what are we dividing? What do we do? Yes. What do you mean take the square root? What's the square root of n to the fourth plus 1? No. Anybody want to explain that one to him? It's my biggest pet
Explain
peeve
which
in the
one?
world. Huh?
Oh, no.
What's that? Right? Does that equal 5? No. Does it exactly equal 5? Right. So what you said is wrong. Okay. Always check the test for divergence first. This is one of those ones that looks like it might work for the test for divergence. Some of the ones like you can look at it like, okay, the test for divergence is not going to really help me much. Let's try something else. What would I divide all these by?
Not n to the fourth. That'd be stupid. You would divide by n.
So we want the bottom to be 1. So that's the goal when you're looking at it. If you can get the bottom to be 1, we're not dividing by 0 and everything's cancels out. So let's divide everything by n to the third. So if we do this, we have n to the fourth over n to the sixth plus 1 over n to the sixth. And then we have 1 plus 1 over n squared. So the bottom comes out to be 1. The top comes out to be 0. So this does go to 0. So it does not pass the test for divergence. So we can't use the test for divergence. We have to try something else. Okay. The bottom goes to 0 faster than the top, so therefore it goes to 0. Yes.
When you put the, 1/n cubed into the curve, would that be n to the 4th over n to the 9th?
No, you're squaring. It's multiplied by 2, not squared. It's n to the 3rd squared, which is n to the 6th.
Oh, yeah, it's exponent. I forgot about that.
That's exponent rule.
Crazy exponent rules. All right. So we know the test for divergence doesn't work. So let's try some kind of limit comparison, right? If I simplify this down to the square root of n to the 4th over n to the 3rd, which goes to n squared over n to the 3rd, which goes to 1 over n. And that diverges. Okay. So that diverges. So let's compare it to 1 over n. So we'll use the limit comparison test.
You just keep changing footprint in mind, right?
So now this goes to square root of n to the 4th plus 1 over n squared plus 1. Now I divide everything by n squared. So I have the square root of n to the 4th over n to the 4th, which is 1, plus 1 over n to the 4th. Then I have 1 plus 1 over n squared, which goes to 1. So since this is greater than 0, and the comparison thing that I was doing was divergent, this is also divergent. Because of the limit comparison test. Okay.
So applied the limit comparison test, we got 1. And because 1 is greater than, wait,
Because 1 is greater than
1 is
0.
greater than 0, it's a finite number, then whatever the B sub n does, A sub n does.
Correct.
Because B sub n
Diverges.
A sub n.
Diverges. Correct.
I have diverges by the limit comparison test. I just did it.
Well, there you go. All right. What about this one?
Can't do it. Impossible. Enough of that. That's for divergence question.
So this one, this is one of those ones that it has the -1 there. So you're automatically going to think that you're going to think the alternating series test. So just do the alternating series test. Because the alternating series test has built in the test for divergence. So, what's the two things I got to show? So first off, Bn is going to be 1 over square root of n plus or minus 1. So I've got 1 over the square root of n plus 1 minus 1 is less than 1 over the square root of n minus 1. That one's pretty obvious. So yes, that works. So the next one, we have to show that the limit as n goes to infinity of 1 over the square root of n minus 1 equals 0. So if we divided everything here by the square root of n, I get 1 over the square root of n, 1 minus 1 over the square root of n, which definitely does go to 0 over 1, which is 0. So this equals 0. So it's convergent by alternating series test.
I have a question.
Yes.
Isn't it kind of obvious that 1 over square root of n minus 1 goes to 0?
Yes.
Do we have to do all the divided by?
No.
Okay.
I did it because if I didn't, I was going to get asked why. Like somebody was going to ask that question.
As they do in the homework, makes me see things clear.
Yes. The more of these you do, the better you get at them. Absolutely. It's just, this is why the homework, there was a bunch of these problems. It was like, just do them over and over and over again. So. All right. 2 more. All right. So do I try with this one?
I went to the internet.
You went through the internet for this one?
But once it showed me what to do, it seemed to be. But I don't know if there's like another.
Yeah, this one's actually pretty straightforward. All right. So what do we know? So this one has that trig function. And so first of all, is this alternating? No. Sometimes the trig function there will make it alternating. This one is not. Because it's not, there's not a pi in there to make it every one. So, but what do we know about sine? Yeah. Right. It's between -1 and 1. So I know that sine of 2n over 1 plus 2n is less than 1 over 1 plus 2n. I know that's true. I also, yes.
Sorry, would it be wrong to say it's less than or equal to?
Yeah, it could be equal to, but that's fine. That's not a problem. So yeah, yes, you're right. It could definitely be equal to. And then I know that 1 over 1 plus 2 to the n is less than or equal to 1 over 2 to the n. That is also true. This is what? That is a geometric series. And R is 1/2, which is less than 1. So it's convergent.
We're done.
And it's greater than this one, right? All my signs go the same direction. So therefore, this is convergent by direct comparison.
So the internet had me slap on the absolute value for sine 2n.
Yes.
And
So you could prove this
Yeah.
absolutely.
Okay.
Because the absolute value of sine of 2n is always going to be less than 1, 2. So therefore, technically,
Yeah.
this one is absolutely convergent by direct comparison. So, which is fine. You still proved it's convergent. I was just asking if it's convergent or divergent. I didn't care if it was absolute or not. So,
I think this was
yeah, it's the math is exactly the same. All right, last one.
oh no, I think I did this right. So I did the direct comparison test and I took away little bits and all the arrows were pointing the same way. So I knew I was good. And then eventually went down to a harmonic looking thing and I know harmonics make divergence. Or I could be wrong. I don't know.
All right, so let's see. So n squared minus 1 over n to the third plus 1. You had that go to,
It's I took away. It doesn't matter. I took away the plus 1 in the bottom.
okay. So that's going to be that way, right?
Correct.
Okay.
And then I took away the minus 1 on top, and that arrow is still 1.
Correct. And then this is 1 over n.
To make that one. And
Right. And this
that-
diverges. Okay. Totally fine. Except for one thing.
Oh, great.
The arrow's wrong direction. If this diverges, and this is less than something that diverges, I don't know if it diverges or converges. Okay. Does that make sense or no?
Because it's less than the other
Right.
one.
So technically, if this one goes like this,
Yeah.
and I know this one's under here somewhere,
Yeah.
it could go that way. It could go this way. Like, I don't know. So, but that's fine. Totally fine. What can we do now? Let's use
That's
the limit comparison test.
So then,
Right. So I have the n squared minus 1 over n to the third plus 1 times n over 1. So I have n to the third minus n over n to the third plus 1. Divide everything by n to the third. This equals 1 minus 0 over 1 plus 0, which is 1.
So diverges.
Yes. Funny thing is, the internet actually did this by the integral test. I don't know why.
Why was it?
I don't know.
I mean,
You could. You absolutely could do the integral test. I would not want to, Like the integral is a mess. This is way easier.
It always looks like a pain in the butt.
Is it?
So is that center part something that we don't want to write down? or-
What, this piece? This part? Yeah, you need that. Because that's how you came up with the piece that you're comparing it to. So the reason why it didn't, so you wrote, so this is when you're looking at comparison tests, you in essence are always trying for a direct comparison because that makes your life simple. So you do it and you got down to 1 over n and everything you've done is fine. The problem is 1 over n divergence. And this series, like it's greater than that. So I don't know. If these arrows were the other direction, I'd have been done. So this didn't hurt. And this also gave me what I needed for my V sub n to do my limit comparison test anyway. So if this doesn't work for direct comparison, you can then directly use that to do a limit comparison. So yes, you still need to do that. If this was n to the 4th, for example, that would have been 1 over n squared and would have converged and I'd have been done. Because then all my arrows are the right direction. Okay. That's your test. Thursday. Yes.
2 days from now.
And I will be here at 4 o'clock. And I doubt I'll be in this room, but I'll have a sign outside telling you which room I'm in. It's probably going to be one of the rooms right over there. I just have to figure out which room doesn't have a classroom in it at that point.
Mr. Knowles is class.
I know his class is open.
Then I'll just barge in.
Like I know his classroom. I know the original classroom he was in is open. That's why I said I could possibly go there. So
No, I mean, I'll just walk into this classroom with him in here. He knows my name.
all right, guys. See you Thursday. And remember, no class on Tuesday. Next Tuesday, no class. You too.